Welcome to my video on 5-4 dividing polynomials. This will be the first half of the 5-4 lesson. And it all stems from a concept that we have learned about in the past, which is long division. So here we have on this screen an actual long division question of just regular numbers. We're going to talk about that process and algorithm, and then we are going to apply it later on to polynomials. Just some vocabulary for us to keep in mind. Under the under the division symbol, we have the dividend. Outside of the division symbol, we have what's called our divisor, the value that's dividing into the dividend. And on top, the answer to a division question is our quotient. So throughout the lesson, I'll be using those words, so just keep them in mind as we go along. All right, so whenever we are trying to divide with using long division, typically what we do is we try to see how our divisor goes into our dividend. Now, we usually do this place by place. So, for instance, we look at this 13. We say, okay, can it go into this first place we have here with the 1? The answer is no, so we move on to the next one. Can 13 go into 15? If it does, we say, okay, well, how many times? So we should know that 13 goes into 15 one time. And then we take that 1 and multiply it by the 13. And then subtract the 13 from the 15 to see how much is left over. Okay. After we do that, we bring down our 7. And we repeat the same process. So how many times does 13 go into 27? Well, hopefully we know that goes in 2 times. What comes after that part? Our multiplication. 2 times 13 is 26. So when I subtract these two, I get 1 left over. We repeat the process again. We bring the 3 down. We say, how many times does 13 go into 13? We know that's going to be 1 time. 1 times 13 is 13. We subtract those two things, and we get a leftover. Now, whatever this leftover is, keep in mind, this is going to be called our remainder. Here, we do not have a remainder, so we don't have to worry about it at this moment. We will talk about what to do with remainders later on. So our quotient, or result of our division question here, is 121, because 13 goes into 1,573 121 times. We're going to keep going with this idea, but this time we're going to use the same algorithm to divide a polynomial into another polynomial. So in this question, we have x plus 5 as our divisor, and we have the polynomial 2x to the third plus 11x squared plus 7x plus 10 as our dividend. Now, we're going to follow a similar process, just like we look to see how many times 13 went into 15. We're going to do the same thing here, except with the x and the 2x to the third power. We want to see how many times x goes into 2x to the third power, basically trying to find out what do we have to multiply x by to get 2x to the third power. Well, we know if we multiply by that x by a 2 and an x to the second power, that if I were to multiply, which we know is a part of our division algorithm, it will give me the exact same term here. So it will be 2x to the second times x is 2x to the third. But because the divisor has 2 terms in it, we have to treat it like a polynomial with 2 terms, which means if I am multiplying this first term by 2x to the second power, I must also multiply the second term by 2x to the second power. So 2 times 5 is 10. X squared, there's no other x's there to multiply, so we bring down the x squared. Notice that in our columns, right, we have like terms, so that's important as well. And so that takes care of that second part of the multiplication, which we did here with the 13 to get here. We're going to do the same thing with the 2x squared to the x plus 5. Now, after we did our multiplication, what did we do? We subtracted. So I'm going to do the same thing here. And I'm just going to use a different color so that you can see. I'm going to subtract by changing all of the signs, because we know when subtracting polynomials that if we distribute the negative sign to all the terms, it's the same as subtracting. So here we get 2x to the third minus 2x to the third. These are like terms, so I can cancel those out. 11x squared minus 10x squared leaves me with a single x squared left over. And just like we did here with our division, we're going to bring down the next term. So I'm going to bring down 7x directly next to the x squared to make another polynomial where I'm going to repeat the same process. So again, we're going to look at how many times does x go into x squared, or what can I multiply x by to get that exact same leading term? And the answer is a positive x. What am I going to do with that positive x? I'm going to distribute it. Distribute to the first term to get an x squared. Distribute to the second term to get a 5x. And again, after we do our multiplication, the next step we have is to subtract. So this was once positive, this x squared, so with a new color, I'm going to subtract it. This was a positive. I am now going to subtract. These leading terms should cancel out if you have done it correctly, and we're left with a 2x. What do? We repeat the process again. We bring down the 10. We say to ourselves, how many times does x go into 2x? What do I have to multiply x by to get to 2x? We know the answer is a positive 2. We multiply, aka distribute 2 times x to get 2x, 2 times 5 to get plus 10. Now I do that same thing of subtracting. So I change all of my signs. These two will cancel, and we get 10 minus 10, which is 0. So again, we have a question with no remainder, okay? But we were able to completely divide 2x to the third plus 11x squared plus 7x plus 10 by the binomial x plus 5. And our quotient was 2x squared plus x plus 2. Okay. Now, I know a lot of us do not like this long division algorithm. Most of us try to avoid it at all costs possible. So there is actually a shortcut for the long division algorithm in Algebra 2 that we learned to help us divide these smaller binomials into bigger polynomials. So this method that we have is something called synthetic division. Synthetic division basically takes all the coefficients from our long division. So this 1, -5, -2, -24 match the 1, -5, -2, -24 under the division symbol. It also takes our divisor value and it brings it on the outside. But you'll notice the divisor value is going to be the opposite sign. The reason for that is because we're basically building in the subtraction part of the question, so we do not have to do the changing of the signs like we would with all of these rows. So what happens? Well, basically, we still are going to do a process of multiplication, and since the negative's already factored in, kind of a subtraction, and we will get a series of coefficients that should match the series of coefficients in our quotient. Okay, so it is just a shorthand for long division. Now keep in mind, we can only use synthetic division on divisors of the form x plus or minus some constant. So it could be x plus 3, x minus 5, but it's going to be x minus or plus some sort of constant. And typically that constant is going to be an integer, although it does not have to. So we're going to do that exact same question that we just did, except we're going to use the synthetic division shorthand. So with synthetic division, the setup is take all of these coefficients and line them up in order in standard form. So we have 2 from the x to the third. We have 11 from the x squared. We have the 7 from the x. We have 10 from the constant. If any term is missing in standard form, for instance, if there was no x squared term, we would have to use a 0 placeholder. So that is something to keep in mind. Now, we're going to put on the outside of this division question the opposite sign of this 5. So if the divisor has an x plus 5, I'm going to put a minus 5 so that my subtraction is already built in. Now, the first thing you're always going to do for these is you're going to bring down the first term directly. So you're going to bring down the 2, and that is going to be the first number in your line of your coefficients. So I bring down the 2, and I now multiply it by negative 5. We know that's a negative 10. That is going to be put directly under the next term, which is why it's important to have place savers if there is a term missing. So now, instead of subtracting, because the negative already builds it in, I can simply just add these two things together. 11 minus 10 is 1. Now I take that negative 5 again and multiply. Negative 5 times 1. And I'm going to put it underneath the 7. Again, the subtraction's built in. So I have 7 minus 5 is going to give me a 2. And then I have negative 5 times 2 is a negative 10. I add these two things together and I get 0. These numbers right here, this 2, this 1, and this 2 are now the new coefficients of my new terms. Now, what are the terms? They will always be 1 less than the degree, I should say. All right, 1 less than the leading power. So if this started with a 2x to the third, this 2 right here is going to correspond to a 2x to the second power, 1 value down. This 1 is going to follow in order of the term. So after your squared term, you have your linear term, which would be 1x. After your linear term, you have your constant, which is 2. Whatever is in this last place will always be our remainder. In this question, we have no remainder, so it's not going to be part of our quotient, but keep it in mind for the future. So we get 2x squared plus 1x plus 2, aka 2x squared plus x plus 2 as our final answer here, which is exactly the same answer that we got using the long division algorithm. Now, with some practice, most of us are going to enjoy the synthetic division process. It's a little bit faster. It has shorthand, not as many variables to keep track of. So it works for us. And that is the one that I'm going to use from now until the end of this lesson and most likely throughout the rest of this chapter. But we do have a follow-up question here that kind of ties into this division idea. And the question is x plus 5 a factor of the polynomial 2x cubed plus 11x squared plus 7x plus 10? Now remember, something is a factor if it divides in evenly. So hopefully we understand that if we can divide and have no remainder, then that divisor is a factor. So in this case, we have no remainder, which means x plus 5 divides into that polynomial perfectly. So the answer is going to be yes, x plus 5 is a factor. Now, why is it a factor? Well, because when we divide 2x cubed plus 11x squared plus 7x plus 10 by x plus 5, either using long division or synthetic division, we get a remainder of 0. There is nothing left over. It divides in perfectly. So keep that in mind. You can use synthetic division, you can use long division to help you decide if something is a factor or not. So if they ever ask you, is x plus 1 a factor of x cubed plus 4x squared plus x minus 6? Our first line of defense will be, can we do synthetic division and will there be a remainder? So with synthetic division, remember, we write the coefficients down in order of highest power to lowest power. So the coefficient here is 1, cubic term. My quadratic term is 4. The linear term is 1, and the constant term is negative 6. We did not need a placeholder because nothing was skipped. On the outside of this division, in our divisor place, we're going to use the opposite sign of this positive 1. We're going to use a negative 1. And we're going to follow the synthetic division process, which states, bring down the first term. Multiply negative 1 times 1. Add these two things together. 4 minus 1 is 3. Multiply 3 times negative 1, which is negative 3. Add 1 and negative 3 to get negative 2. multiply -2 times -1 to get a +2, and add these together to get a 4. Now, we know that this would correspond right here to a 1x squared. This corresponds to a plus 3x. And this -2 just corresponds to a constant of 2. But this value at the end here stands for our remainder. And if something has a remainder, we know it is not a factor. So the answer here is no. X plus 1 is not a factor. And we know it's not a factor because it does not divide evenly into that polynomial. So now you may be asking, what do I do with this remainder? How do I handle a remainder in a synthetic division question? Well, it all ties back to our understanding of regular old number division. When I divide a number by its divisor, I do my long division. I could do the long division here, right? 4 goes into 13 3 times because 3 times 4 is 12. I know I have a remainder of 1. Well, with regular numbers, we take that remainder and we always put it over the divisor because it's saying that I have 1 out of the 4 left over that didn't get factored into this division question. We're going to do the exact same thing here with our remainder, but we just have to be mindful of some notation. So we just looked at this question. Is x plus 1 a factor of this polynomial? We did our synthetic division. What do we get? Well, we already know we have an x squared plus 3x minus 2. But what we're going to do to this with our remainder is we are going to add it and put that remainder over the divisor, which in this case is going to be the binomial x plus 1. Okay, so that is the correct notation that you are going to use to describe your synthetic division answer. Okay, you have your quotient, you add your remainder over your divisor. So let's try one more question. Divide using synthetic division. Then decide if it's a factor. So here we have it in a little different format. We have fraction bar, but we know fraction bar means division. Okay, and we know that x cubed minus 13x minus 12 is going to be our dividend. And we know x plus x minus 4 is our divisor. So let's set it up. We have x to the third has a coefficient of 1. However, there is no x squared term. So this is what I was talking about as having a place saver. We should put a 0 in between because we have no x squared term. And that is because basically what we're doing is we are adding a 0x squared. So we put a 0 there. Then we have our linear term, which comes next. And then we have the minus 12. On the outside of our division box, we're going to put the opposite sign of this, which if it was -4 is going to be a +4. And we follow the synthetic division process. So we bring 1 down. 4 times 1 is 4. We add 0 and 4. 4 times 4 is 16. We add -13 and 16 together to get a 3. We multiply 4 times 3 to get 12, and we get 0. When the answer to the divide portion is our quotient, which would be x squared plus 4x plus 3, and there's no remainder, so we don't need our fraction. And we answer the second question after. Is it a factor? The answer is yes. X minus 4 is a factor because there is no remainder. Now, if you need some extra practice questions from the textbook, these are the practice problems that correspond to these ideas. Please do your best, and best of luck.